In example 1, we're given a graph of y is equal to f of x, drawn here, and the goal is to solve these 4 different equations for x. We're going to use this above fact that anytime you adjust the x values of a function, it will result in the opposite effect on the graph, but more importantly, our answer. So let's look at this one here. We started with f of x, and this is x minus 2. That means we've changed what the x value is. And over here we have 5, which represents the y value. So what we're trying to find are all the x's that would give us this y value of 5. So step 1 would be, can we locate this on the graph? So I'll find 5. It's right here on the y-axis. And the place where it equals the function is right here at x is equal to 3. So I'm going to make note of this. If I put 3 into the function, I get 5 back for y. That is, f of 3 is equal to 5. So if I go to solve this very first equation here, where's f of x minus 2 equal to 5? I want to make this x minus 2. I want to make that equal to 3. This is where we're going to use this idea of the opposite effect. Because here is 3. And this is x minus 2. You would think that you would take this x value and subtract 2 to go to 1. But in fact, the opposite effect would be to add and take us over to 5. So this minus 2 is actually going to move us in this direction. So it doesn't go smaller, but it gets bigger. So we're going this way. I'll write down the answer and then check to make sure it's correct. So for f of x minus 2 is equal to 5, I'm claiming that the answer is 5. And the reason it works is because when you plug it into the equation, so you take that 5 and put it in place of x, it simplifies to give you 3, and we know that f of 3 is 5. But the big takeaway was this minus 2 actually resulted in adding 2. So let's check this out with the next one, which is very similar. F of x plus 2 is equal to 5. So the opposite effect at this value is going to be to subtract 2 to go to 1. So to solve the equation f of x plus 2 is equal to 5, I'm actually going to go 2 places to the left. And so my answer is going to be 1. To see why this worked, I'll take that value 1, put it in place of x, and when I simplify it, I get f of 3, which I know is 5. So we've solved the first 2 equations. Again, I knew that I wanted this to be a 3, I wanted that to be a 3. Here I actually had to add 2, and here I had to subtract 2. If we compare this to the next 2 equations, here I'm dividing by 2, and here I'm multiplying by 2. So when we talk about adjusting the x values in an opposite way, if this is division by 2, the opposite effect will be multiplication by 2. And since this is multiplication by 2, the opposite effect will be dividing by 2. So let's just make sure that this trend holds as well. All right, step 1. I have to first find, for this equation here, where the y value is 0, and then locate the corresponding x values. So here's y is equal to 0, and this is the only spot on the graph that has this value. So I'm going to mark it here. I know that f of negative 2 is 0. I put negative 2 into the function and I get 0 back for the y value. So let's see, if I want to solve the equation f of x over 2 is 0, I'm going to take this x value, which is negative 2, and I'm actually going to multiply it by 2, which would give us negative 4. So what I did is I looked at this spot, it was at negative 2, I saw division by 2 in this equation, so I actually doubled the x value and went over here to negative 4. I'll now plug that into this equation to see why it in fact works. All right, so when I do, that's f of negative 4 over 2, is that equal to 0? And the answer is yes, because negative 4 divided by 2 is negative 2, and we already know that f of negative 2 is 0. Let's try that with our last equation here. So again, I'm multiplying the x value by 2, and it means I'm going to take this x value and divide it by 2. If I divide negative 2 by 2, it goes to negative 1. So we're going this way. Let's check to see that this works. I'm trying to solve f of 2x is equal to 0. I took the x value of negative 2 and I divided it by 2, which gave me my solution, negative 1. And if I plug that into my equation, I get f of 2 times negative 1. Is that equal to 0? And of course the answer is yes. When you multiply 2 and negative 1, it does give you negative 2, and we know f of negative 2 is 0. There's a lot of work that I put down here for showing that these are true. This is not going to be necessary for us as we go forward. I mean, essentially, it should be as quick as, oh, I know this should be 3, and I see a minus 2, so I'll just add 2. Oh, it should be 5. And like this one here, okay, I see a plus 2. Okay, that means I'm actually subtracting 2, and I get 1. So we don't have to always show this work, but I'm just trying to illustrate why this fact is true.